and then we can just get Kelly the recording. She can catch up later. Okay.
Mhm.
So we're going to talk about the tools first today. We're going to talk about placement of the walls, slabs, columns, beams. We'll go through the doors and the windows very briefly. We'll talk about the object tool and the roof tool. So if I'm just going to sort of mock this up as the building or a building like it. So with the wall tool, as you've already obviously figured out, there are all these settings in here. We can link the wall to the floor height. That's the vertical dimension. The advantage to this is that it gives us global control, right? So if this is linked to the floor height, this wall is 20 feet tall because it's 10 feet above the next story up. If I change that to 0, it's a 10-foot tall wall. The nice thing about that is if we were to come in here and change our floor height, that wall is going to stretch with it. That
Mhm.
said, obviously for things like maybe half walls, screen walls, railings, stuff like that, we might not want the wall to be linked to the floor height. But otherwise, that's fine. And it's actually preferred for most walls. Now, we also have sort of this is the vertical dimension where it sits relative to project zero, to its home story, its total height, relationship to the story is all controlled here. We also have controls over what the cut profile of this looks like. And there's three different shapes that basically we can extrude for the wall tool. There's a basic building material that's just a cut appearance. If I had, let's say, an 8-inch concrete wall, I could set that here. Now, the disadvantage to this is if I place a whole bunch of 8-inch concrete walls, I have to go through and find all of the 8-inch concrete walls and say that those are 10-inch walls in order to change the width of them. And that might be hundreds of walls in a big project. So the better approach is to make it a composite, even if it is just a basic concrete wall, right? Now, if I were to update, let's go ahead and just draw a concrete wall in here. Um, I'm going to right click and say edit, select a composite. Now I'm not going to reserve over the top of you, but if I change this dimension in this attribute setting, the whole wall gets wider. So I don't have to go fishing for where those walls are that are 8 inches. I can just come here and have a single point of control to say that engineer says my 8-inch walls need to be 10 inches, and I can change it globally project wide. So even if it is just a basic extrusion like this, where it's just concrete, the composites are better because it gives you global control. Most of the composites are going to be things like our exterior 2x6 wall. These can have all of the various layers over the top of them, right? So it can have the siding over the sheathing over the studs, chipboard, tile, whatever we need. These can be built up out of complex extrusions, but they're all parallel extrusions. There's no like complex shape. And the third option is actually a complex profile, and that can be any shape that you draft. Um, I don't particularly like complex profiles for walls, and we'll talk about that when we get into the attributes tomorrow. Complex profiles are great for beams. For walls, because the way walls try to join each other, it doesn't miter the corners and it adds a lot of extra polygons for like say complex crown moldings or things like that or baseboards. So generally speaking, our wall tool is mostly going to be these composite extrusions. We can also make the wall canted, sloping, tapered, various shapes, but generally speaking, we're not doing a whole lot of that. Not that we haven't had sort of canted walls or tapered walls, but it's not very common. Now, this might be actually the most critical part of really any tool, and that's the origin or the reference of that tool. For the wall, we have the reference line. So here we see we can put it on the outside face of the wall. We can put it on the outside of the core, which is pretty typical for a wood framed wall, right? And if we zoom in on this, you can see that blue fill is the core. That's the 2x6. And then I have sheathing and I have siding. And that blue line right there is the reference line. So if I were to change this to, let's say, a 2x4 wall, right? The wall shrinks in towards that reference line. So that reference line is the fixed position. Even if I were to say that we have a 3-inch offset from where that reference line is, that reference line does not move. That's the fixed position of that wall. So you're really designing around that origin. The wall is just extruded along that vector. Um, oh, here's Kelly. Hey, Kelly.
Hi guys. Sorry I'm late.
No problem. We're just talking about the wall tool.
Okay.
Um, I don't need to do that. Why is it taking a screenshot? All right. So that's the basic geometry of the wall. We also have floor plan settings of the wall because a wall might be visible on multiple stories. You know, if you have like a crawl space plan versus a basement plan, maybe that crawl space wall sits in one story and needs to be visible in multiple stories. There is an option here to show on all relevant stories, and we're going to talk about what makes a story relevant here when we get into the view settings. Um, there's also the ability to show it as symbolic cut. That's like no matter where it's at, it's going to show with its cut fill. You can show outlines only. You can show cut only. Different projection types, how it's going to show up in floor plan. So this is which stories it's going to show on, and this is how it's going to show on those stories. And then sort of the last thing that's worth mentioning here is the surface overrides. We do use surface overrides a lot in ArchiCAD. And when we get into attributes tomorrow, that's going to make a lot more sense. But basically, we have this composite. This composite is a series of layered up building materials. Um, but the surface override is like the wallpaper that we put on it. This is what it looks like uncut. This is what it looks like when it's cut. The reason that we use the surface overrides is because we don't want to have, 5,000 different building materials in our project. We don't need, we have like tile as a building material. We don't want to have 15 different tiles for the cut appearance. Tile should just look like tile. And again, this is something that we're going to get into when we start talking about these attributes tomorrow. But this is what it looks like when it's uncut. So like if this is, actually this would be so if we put siding on this side and chipboard on that side, that's what that wall looks like. If I isolate that out, there's that wall, right? Now, if I want to draw in, let's just say this practice model here, I'm going to go to my geometry method here, and we'll say that this is 45 by 30, and we'll just draw that in like that. Okay, so that'll be close enough. I'm going to put a little, we'll just try and mock this up somewhat like practice exercise. All right, so there's my walls. Um, Now, I mentioned this yesterday, but the drag copyright Command Option D going to be super useful for you. A lot of times I'll just mock up a building with walls like this and start trimming them out. So it might be something like this, right? And then really just going through and trimming those out. Command click to trim those out from each other, and then we get something that resembles the plan that we're working on. Um, the slab tool here. Um, Similar to the wall with the exclusion of the complex profile, right? Because this is an extruded plane, it's not an extruded vector. So there's no option to have a complex profile, but we can have the composites. So here, if I have like a concrete deck over gravel, might be an appropriate composite. We can put the reference plane either at the top of the slab, the bottom of the slab, the top of the core, or the bottom of the core. Where the walls might have the reference line on the outside face of structure because that's sort of uh, construction standards or architectural standards to dimension to the outside face of core and to design to the framing. Um, on our slabs, whether it's a ceiling slab or a floor slab, we're typically designing to the top of the slab. So we're really looking at the floor to floor height, making sure that all of our floor finishes flush out where we intend them to. We're never going to have like an 1/8 inch drop from tile to wood or something like that. We're always going to make sure that we're designing. In fact, a lot of times our framing plans get really complicated. And our concrete plans, we've even done slab plans to like have 1/2 inch drops in the slab in order to accommodate different finished floor materials. So we're designing to the finished floor. And then same with the ceilings. If it's a ceiling, we would put the reference plane at the bottom of the ceiling slab. So we're really talking about the finish height of that space. The floor plan show on stories option. Now there is no projection here. It's either overhead or it's not. There's no like way to show it projected with overhead, but we can say that it's going to show on a whole different range of stories. Unlike the wall that's going to show on home story or all relevant, here we can say home story and 1 story up, home story 1 story down, 1 story up and down. We can even create a custom story range for it to show on. So you have a lot more flexibility on which stories a wall shows, or sorry, a slab shows on over a wall. Um, The thickness of that slab is set by the composite here. If I had a basic extrusion, I can make that as thick of a slab as I want. But here we're just going to say that this is going to be a 4-inch concrete slab over gravel. It's height to home story, it's height to project zero. And because first floor is at zero to project zero, those things are equal. Here we can override the surfaces. We could say that this thing needs to look like concrete, or if it was a wood slab, we could show it as wood. Um, Here we have the cover fill. So if you had a board pattern that you needed to show in your floor plan, this is where that would show up. And here, this option to use the fill from the surface is going to use whatever fill is applied to this surface. And again, this is where like we sort of play leapfrog with the training lectures because all of these things do interweave each other. So we are going to talk about surfaces and all of these other attributes tomorrow in our first session. Um, when I go to draw the slab, it's as simple as just dragging. The geometry method is also available for um, a slab here. You can basically click on each edge. Another way to do that is to, if you already have the vector defined, you can hold the space bar and it will actually trace out connected vectors. So you can magic wand an area with a slab, or you could do it the other way around, where if I have a slab, I can magic wand the walls around that slab, and that's just space click. Okay. Um, Next is the column tool. So looking at the column tool, we have our dimensions of the column. Let's just say it's like a 10 by 10 column. So here it's showing round. I'm not going to worry about that too much right now. That's in the segment settings. The column and the beam tools were updated about a year or two ago. And so the user interface is a little bit different for those tools from other tools in ArchiCAD. It's actually kind of nice how we have like all of the settings over here, and then each of those settings have their own sort of controls on the right side. Um, where the slab has the reference plane and the wall has the reference line, a column has a reference point. And that reference point can be on any of the any of the eight edges and corners or in the center of the column. And just like the wall where it's going to grow or shrink based on that origin, if, for example, I place it on this outer edge right here, and let's go to the segment, and this is where I want to say that this is a rectangular column. I'm going to say that this is wood framing. It's still a 10 by 10. And we'll make it trim. Oh, wood SD, we'll use that one. Now, if I hover over this corner, I should be able to, on my y-axis, say that this is like 12 feet up, and it should dump it right there. Yeah, so there's that column. Now I put the reference line on the upper right of that. So as an example, right, if we said that this is going to be a 5.5-inch column, right, I reduce that down. Notice that that fixed point right there stays where it was at. And this is one of the disadvantages to the column is there's nothing in that column that says, hey, the reference point is here just by selecting it. Unlike the wall where I can actually see that that reference line sits right there. And I think because of that, I think a lot of people just place it in the center and don't worry about where it's at. The reality is like resizing these things, you kind of got to fuss around with it anyway. So now if we go ahead and drag a copy of this from here over to here, and I'm going to mirror that. Oops. We'll go out another 12 feet. Let's do this. We'll do that. Okay. Now we also have the multiply command, Command U. So I can say that I want to distribute, I don't know, like 5 of them. I forget how many there are. And that's a quick way to, that's way too many. Anyway, gets the idea across. Right, so I have these now, and I can drag a copy of these over to here. Just really quickly kind of mocking this up. Let's put these ones out here. Distribute those around. So now we have our columns around the perimeter. The columns also have options here for them to be vertical or slanted. The end cuts of a slanted column can be horizontal, they can be vertical, or they can be at any custom angle. That allows you basically, if you have like, let's say a sloping bar drafter that dies into a vertical piece of trim or something, you can miter those things together with custom end conditions. The beams are also able to interact with walls in kind of interesting ways. So here, these are going to clean up because they're the same building material. But if the column is set to include the wall as a wrap, we'll actually show that finish of the wall wrapping around it. So we don't have to meticulously model the finish around a column that's integrated into a wall. I don't know that there's a lot of projects that that matters for, but it is useful to know so that you don't find yourself wasting hours and hours and hours modeling chipboard around integrated columns. Additionally, in the column settings, there are these segment options. So if we had, I'm trying to think of options of or conditions where we might show segmented columns. Um, Maybe if we're looking at a built-up column or a wrapped column, we can apply a segment and we can say that the lower segment is a fixed length. Maybe that's 9¼ inches tall, and maybe it's an extra inch wide. And that's going to basically, that piece right there now will have those dimensions. If the column stretches, this piece is basically the stretchable portion, and this piece is a fixed 9¼ inches out of that total 10-foot height. So you can actually have built up complex columns. I know that we've done this before for like steel column profiles where maybe it has like a square base plate and then an I-beam profile. You have options for each segment to have its own shape. So you could have potentially like a steel I-beam. Let's figure out like there we go, a steel I-beam over the top of maybe a like 1 inch base plate or something. You can build these up out of a single column. They can also be tapered, right? So even this piece right here, if it's able to change shape, we could taper that so that it has like a flare to it. That's all based on that reference point though. So if it's fixed on one side, the taper, you can see how that offset's kind of weird there. Um, it's one of those things that we're not really going to use a whole lot, but it's useful to know that it's there. Um, see. Yeah, and then otherwise the profile options are square, round, or anything complex profile wise that you can draft. That could be literally any extruded shape. It could be like a piece of wood ram's crown or crown molding or complicated trim or even like built up fascia and soffit and corner boards can all be whatever you can draft, you can apply to the column. For the floor plan and section display, let's cancel out of that, go back in again. Floor plan and section display here, similar to the walls and the slabs, we have options for which stories it's going to show on. And just like the slab, we have a lot more options for the column than we do for the walls. We also have options for projection with overhead, cut only, symbolic cut outlines, etc. There's also a symbol, so we can actually have the X pattern through that if we need it. Anytime you see structural analytical, ignore it. I didn't mention this for any of the other tools, but classifications are basically this is the BIM information hub of ArchiCAD. This is where like if we're working with consultants that are using Revit, we want to make sure that the classification of this is set to column if it's a column. That means that it's that basically is what determines what family it's going to be applied to on the Revit side. Um, if this is a piece of trim, we would want to classify that as a covering. If you get into IFC Exchange, we can certainly go through this in more detail. But this is basically, this is not a column because it's using the column tool. It's a column because it's defined as a column by its property, or its classification rather. So this is really the critical part in model exchange is applying proper classifications to elements. For basic generic modeling and our internal use, these don't really do a whole lot for us, but they are really critical and vital for sending IFC files to and from consultants. For the beam tool, let's take a look at this tool right here. The beam tool is similar to, in fact, almost in every way identical to the column tool. Primary difference is a column can never be horizontal, right? It always has to be like 1 degree above horizontal. A beam can never be vertical. The other difference is that the reference point for a beam is actually the axis. It's not a reference point, it's a reference line or a reference axis. Here it's grayed out, I'm guessing because this is a missing profile. So we'll just say that this is, we'll make this also wood framing and we'll make it a 6x10. So here's my 6x10 beam. Um, the beam settings, we can have it sloped. We can even have arched beams. The end conditions of those beams, just like the column end conditions, can be vertical, horizontal, or any custom angle. We're going to take a look at that in more detail here in a second. We're also going to take a look at the segments of these beams. We'll get to this today actually because I do want to talk about these beams as a rafter tail tool as it pertains to the practice model. So in this case, I'm just going to go ahead and click here and oh, let's change this to this geometry method. And we'll apply this around the porch here. And I'll add this one right here. All right, so now I want to take a look at my 3D model. I'm going to select this, and like we talked about yesterday, if I want to see a selection, I hit F4, and there's my beams, my columns, my walls. And this is where like kind of following through and adjusting things as you go is really helpful, not getting pigeonholed. Just because we're only looking at 2D floor plans, maybe it's an early SD and we only need schematic plans. If that schematic plan includes a model that's halfway clean, that means that when we get into mid SD and we starting to look at renderings and elevations and stuff, we're not like scrapping it all and starting over. So a little bit of time and consideration ahead makes modeling down the road a lot quicker and cleaner. Um, Here we also have the surface overrides for each of the faces of the beam as well as the end faces of the beam. We have the option for multiple segments, just like with the column tool. Floor plan and section, we can show like which stories it shows on, how it shows on those stories. Projected with overhead means it'll be dashed if it's overhead, which is probably preferred here. So if we go and say OK, you can see how that one's now dashed because it's set to projected with overhead, as opposed to this one, which is solid. So if I eyedrop that, option click, and then command click, those are going to match. Okay. Um, Let's take a look at the door tool. I'm going to actually model the big surface sliding door here as an example. So if I just drop a door in here, this door is set from the favorites here, and that star. So just setting it here means that I don't have to worry about what the marker type is, what the pens are. It's the correct door. It just doesn't have the correct operation. So the door tool, if we look here, there is the CI CAD image doors. There's also everything in the ArchiCAD doors. We do not use these doors. There's just a ton of doors, and not one of them is going to be able to do the 4-panel surface slider that we want. You know, if we went to specialty doors and sliding doors, there's a 2-panel surface slider. There's not a 4-panel surface slider. So we're going to use the CAD image door that we have right here. There are 3 CAD image doors. We're primarily using the CI Tools door. There's also the CI Tools garage door. We should have a favorite for that. I guess I need to create that. But that's sort of its own special thing. If you do see a library dialog like this and you want to switch a library part, if I just click on it, it reverts to its default settings. So the way to change from one part to another is to actually hold Option and Command, and you notice that my mouse now has a syringe. I can eyedrop this door type into this door. So now I'm using the correct pens. I'll have the correct floor plan marker. Everything's going to look correct. I just have to adjust the door to be the right size and type. But for the 4-panel door, let's go ahead and go into the settings here. And there's a lot in the door settings here. And that's the trade-off. We have one door that kind of does everything, but it means that there's a lot in the settings. Primarily, I want to focus on the door type and the door leaf. So for example, the door type here, um, you can set the door type to be right and left different so that I could have like, for example, a bifold door on one side and maybe it has like 5 panels and then a swing door on the other side. In this case, I just want to say that they're both 2 panels on each side and they're going to be uh, surface sliders, right? So there's my door. I'll say that this is, I don't know, 22 feet by short 8 feet. Now the door size here is basically the door dimensions plus the frame. So it would actually be 22 feet 1.5 if it needed to be a 22-foot door leaf. Um, And then in the frame settings, this is where you would say that B dimension is what that frame is going to be beyond the door leaf. A, that's the frame depth here. If A is set to 0, it's going to match the wall thickness. So the frame to match wall thickness is A equals 0. So you don't have to figure out every single wall dimension. Just making that 0 is going to automatically make the jambs match the wall thickness. Um, you can adjust the setback of the door from the frame. So if I wanted the door to stand out from the wall a little bit, I can even give it a negative setback. We'll say okay, and we'll see what that looks like here. You do notice that the trim pops on here. That is on by default in the favorites. Um, Most of the time, we're going to actually turn that off. It's okay to have on for like a schematic model, but down here, we do have exterior trim. We could say no trim, and then interior trim. Turn that off as well. And the reason that we don't usually use the integrated trim, and I'm not going to say always, a lot of times we'll have projects where we just have basic square stock trim and it's going to be either close enough or it's going to be exactly what we want because it's simple enough. But anytime you see any tool that has this many features packed into it, it's always going to fall short in some level or another. You're always going to have like that one condition where like, oh, we can't model that with this integrated tool. We have to model that as separate components. Other examples of this are like the stair, the railing tool, the curtain wall tool. They're all very flexible, super versatile tools, but they just fall short so many times. So it's the sort of thing where like trying to get the trim to do exactly what you want with the integrated trim into these doors may work, but if you spend more than 15 minutes trying to make it work, just abandon it and model it with beams and columns because you'll save time in the long run over trying to figure out how to get this to be close enough. And our standards are never going to say, okay, it's close enough, we'll move on. We're always going to want to be as exact as possible. Um, so beyond the door type, the basic operation and configuration of this, we also have the door leaf type. These thumbnails here get a little bit on the absurd side as you scroll down them. They look like ugly Home Depot doors. So we don't use a lot of them, but the first couple of rows, maybe 2 or 3 rows are okay. We also have the option for custom doors, and we're going to get that into that towards the end of the week, or maybe even early next week, depending on how long we go on training this week. But these little thumbnails have, if we look here at the preview here, they have 3 different colors of teal, right? The darkest color of teal is anywhere in here that talks about the door leaf. Maybe it's door leaf material, door leaf pens, leaf thickness. It's talking about that darkest color of teal. Anything that talks about the door panel or panel insert is going to be the medium teal. So here I see panel insert and that's set to glass. Let's go ahead and make that flat and you'll notice the door becomes solid. But on the practice model, the sample model, how the local vi, it's actually glass over a panel. So I'm going to select this one right here. And we have dimension settings. We can set this to 2.5 feet. Um, we can set all of the rails and the styles of this, however we need it to be. So it is a pretty flexible door. These first 2 or 3 rows have some pretty decent doors. Now I have the glass, but I need to adjust the glazing bars. So here I'm going to say that we have a basic grid on those, and we have the A and B dimensions as well as the mullion dimensions. So the A, B dimensions are what's the smallest pane of glass that will fit evenly between that dimension. So if we say that this is, I don't know, like 2.5 feet, or maybe 2 feet and 2 feet, right? So we get that sort of panel breakdown. This door is fully closed. If we wanted to show it partially open, that's down here under display options, margin of sliders. Maybe it's like 6 feet open in plan view. Our CAD image is great because we can show it open or closed in plan view. We can also show it at different openings in 3D and section elevation and in 3D document. And 3D document is a specific type of viewpoint that we'll talk about here in a little bit. So there's my door partially open. Okay, now let's take a look at the window tool. Again, the window tool, we're going to go into our favorites. We have corner window and a basic window, and this is just the fixed window. And it's similarly, it's just the CAD image window. There's only one CAD image window available. And there's a lot in here. Just like with the doors, there's trim, there's frame settings, there's sash settings. But I'm going to start with the glazing panel layout. Where this is different from the door is that this little thumbnail is actually an interactive piece. So if I click on this, I can actually add additional leaves. Um, if I add additional leaves, I can select just the left leaf and say that this is left hung. I can say it's a fixed pane. I can adjust basically left to right what the dimensions are. I also have the ability to insert a panel below so that I could basically say under the key dimensions here, that panel below is 2.5 feet, so that matches the door. And the total height on this maybe is 8 feet, right? Matching that door. Um, and then under glazing panel layout, I could say instead of a fixed sash, I could say that this is a panel, and that should match what's on the door. Um, Additionally, I could say that the upper piece is a hung window, and there are single hung and double hung, but because this is it's a New Zealand based program, so nothing is actually called what we would call it. Oh, there we go. The double hung window is called what we would call it. Um, and then we also have options for click right here, for the glazing panels, right? So we could set the glazing panels here to match whatever needs to be in the door. And then placing a door or a window, I'm just going to hover over the wall. That little sun icon indicates which side is the exterior of the window versus the interior of the window. That comes into play when we start talking about like exterior trim, interior trim, connecting it to zones, a few other things. But really, I'm just going to place here and then which direction, if it was swinging, would the swing go? Okay. Um, so that's the door and the window tool. There's a lot more to the windows. Like we can even adjust like the head shape. The head shape here. This might be for like the gable end vents in the roof. We can use a window and basically say that it has a gable shape, and then you can shape that with the window tool, so you don't have to model those louvers individually. Um, For the roof tool, I'm going to jump past the object tool for right now. The roof tool, we have two different geometry methods, and I'm going to start by looking at the single plane geometry, and I'm going to model the porch here actually with sloping slabs. So I'm going to select the roof. I'm going to come into the settings, and I'm going to say that this is a concrete over gravel to match my floor slab. Um, Maybe it's a 1/4 and 12 slope or an 1/8 and 12 slope. Um, the slab has a composite setting. It has a single plane. It has a multi-plane. The edge conditions can be different shapes. A lot of different options here for how to shape the slab and how to use the roof tool for these things, like shower pans and stuff like that. That's where when I was talking about like the roof tool, or sorry, rather the wall tool is not a wall, or the column tool is not a column, just because we use that tool. It's actually what it is because of this classification. So in this case, I would say that this is not a roof, it's a slab. So I'm going to call this a slab, um, and porch slab, and all of this feeds into what our consultants are going to look at in our model. The roof can show projected with overhead, home story only, 1 story above, 1 story below, outlines, project or cut only. So there's different ways that we can look at these roofs. For the single plane roof, I'm just going to put the reference line here to the outside. And it doesn't really matter how long that reference line is, but we're going to draw that there. And then that little eyeball angle symbol is which direction is sloping upward. So I'm going to slope it up this way, and I'll draw it to here, right? So now if I mirror this across at a 45-degree angle, we'll do that one more time. Let's get this in the right position here. All right, so now we have a roof on each of these faces. I don't know why this one's short, but we'll just pull that to there. And let's take a look at what those look like in 3D. Right, so nowhere near where I want them, but this is where kind of cycling through and looking at things at different angles really helps. Let's also go into the model setting here, and we'll make this concrete. Say okay. Now I want these to come together so that they're all clean. So I'm going to select this roof, and if I hold Command, I get the scissor icon, the trim, and I'm going to trim this roof to this one. And then I'm going to select this one and Command click this corner. Select this one, Command click that corner and that corner. And from here, I can just grab these and drag them to that point, right? So there I've got my sloping floor slabs, the porch slabs. Um, Thinking about other ways to use slabs, like maybe there's a turn down footing around this whole thing, right? So let's take a look at that. So if I take a slab, let's go down a story, command down will take me down a story, and I'm going to show above the current story here. And I'm going to make a rectangular slab that is just a concrete slab. And maybe these are 18-inch deep footings or something like that. So I'm going to draw a footing here. And if I click on an edge, I get the pet palette. The pet palette is going to allow you to edit and manipulate things. And it really depends on whether you click on an edge, a node, or a surface, which palette you get. But definitely play around with the pet palette here. In this case, I'm going to offset all edges of this slab. And I'm going to hit the Option key as I'm offsetting all edges. And you notice that my cursor now has a plus. So I could say that this is a 2-foot offset. So now I have a slab here that's offset 2 feet in from this slab. I'm going to take this slab and subtract out this inner slab. And then I can delete this piece. So now I just have a boundary slab. I could also add maybe that there's a strip footing that comes across right here. So I can use the plus option right here to crop that out. I can use the subtract option to subtract that out. I can offset edges in. So if we offset all these edges in to match there, now I've got all of my various strip footings around the building. If we take a look at this in 3D where that footing is at, right? Looks okay, but we can even take it a step further. We can say that maybe this inner edge here in 3D, I'm gonna isolate that out. So select the slab, select that geometry. Notice the blue line is only around that inner edge. And I can say that maybe this has a custom edge. On the pet palette, I'm gonna click right there and say selected polygon, has a custom angle of, I don't know, 85, or let's make it like 60 degrees, right? So now I get that slab that's tapering in like it would be on a turn down. Um, I would probably want to do these individually because I want this to be a vertical face still, but you can do that. You can click on this edge and say that this edge is a custom angle at 60 degrees and just go around and apply that all the way around there. But in a few clicks, you get something that resembles a foundation. I'm going to dump in section right here. We'll just take a look at what this looks like. So I can see here that these footings are way too low, so we'll go ahead and pull those up. And they're not playing nicely with these porch slabs, so we'll take a look at how to fix that. So if I select these porch slabs and say Command 0 is going to give me my solid element operations, I'm going to say that those are my targets, and this is my operator, and I'm going to do a subtraction, and that'll clean up those intersections. Could do the same thing here. We could say that this is my operator, this is my target, and do a subtraction. Now we get a nice clean building section. So the solid element operations, the SEOs, they're basically Boolean functions in ArchiCAD. We'll take a look at that here when we get to the roof in a little bit. So now I want to go to the roof and we'll say show below current story. And I want to demonstrate the other roof method here. So if we go to the roof tool and we say that this thing is going to be a multi-plane roof, and we'll say that it's a 3 and 12 slope. The roof is going to be, we'll say it's roof 2x6 metal roofing. Standing seam, that's all fine. We'll leave it at that. And then from here, I don't have to define the reference line. I can just click across and make it a rectangular roof. This is really the advantage to that multi-plane roof is that really quickly you get basic hips and valleys for any shape that you need. It does have that reference line, but also it has the ability to just universally say we want to have a 6-foot roof overhang, right? And I don't have to go through and adjust all of the roof overhangs individually. That said, I don't recommend the multi-plane roof for anything that's more complicated than basic hips and valleys. If you have varying plate heights, a lot of shed roofs and things like that, they definitely should be single plane roofs. You do have the option, you can right click and split into single plane roofs. The disadvantage to that is that's a one-way street. Once they're single plane roofs, there's no way to go back and say, oh, I actually want these to be unified again. You basically throw it out and start over if you need them to be a multi-plane roof. So if we take a look at this, oh, actually, looks like I already have this set up to do most of what we wanted it to do. Let me backtrack here just a little bit to illustrate what's going on. So the multi-plane roof is also able to have pitch breaks. So in this case, it's a 3 and 12 roof, hip roof. But what I can do is I can add a pitch break and I can say at, I don't know, 1.5 feet up, it's going to go to 6 and 12, right? So then I have that pitch break that happens right here. If we look at where that's at here, I can use the pet palette to offset where that's at. So if I want it to be, I don't know, like 3 feet out, I can click here and go 3 feet and it'll pull it 3 feet out from that roof junction. But I also have the gable ends that I want to show in here. So let's go ahead and add those in. So we'll add another pitch break up and we'll say that that's still 6 and 12. Oh, and let's pull this in just a little bit. Something like that. And what we look at here is there's that other pitch break line, but it's a 6 and 12 to 6 and 12. But what this allows us to do is to grab the pet palette here and start sculpting this. So we
Mm.
can get to some really cool designs with the multi-plane roof, but really this is sort of the limit at what we can do. For those shed dormers, those are going to have to be modeled as individual roof planes. I can click here and pull this out. I can give it an overhang here and an overhang here. Um, right, if I come back into my floor plan, I can grab my wall tool and put a wall right here. A wall right here. Let's take a look at that. Right, so these walls can come up to here, and then, like I was mentioning, I'm hoping that they're not cutting through there. These can be my targets. This can be my operator. I can do a subtraction with upward extrusion, and that should trim those walls out at that roof line. Okay. Um, Now for the shed dormers, that is going to be a case of a single plane roof. So that would be probably off the ridge right here. And I'm going to be sloping up this way, but actually making it model out this way. The reason for that, isolate that, pull this up to here, right? So if this pitch needs to change, I put the pivot line right here at the ridge so that, I don't know, let's make it like 2 and 12. It's actually pivoting off of that ridge point. So I'm not going back through and redesigning the whole building based on the bottom point. It's fixed to the ridge. And that's where, like when I was talking about the reference line on the walls and the reference point on the columns, if you sort of plan ahead on where those origins are at, making changes to the design later on is a lot quicker and easier and cleaner. For the walls that go around this, I would probably model that in floor plan, but really just sort of, I'll quickly rough something in here. Oh, that's way crooked. Anyway, it would be something like this, where I would have walls that came right here and trim those out. This is where like knowing which view to model in is really important so that you can be precise. But similar to what I did on the gable end walls, I would model these dormer walls as separate walls. If these were going to be open dormers, and I know for a fact in this particular project, if you look at the sections, those dormers are not open, but if they are, you can punch a hole in the roof just with the subtract option, just like we were looking at with the slab tool, right? So you can create an opening here. You don't need a solid element operation for every single trimming body. The important thing there is don't click on the blue line and subtract. Otherwise, it's going to create a whole new, the blue line is the reference pivot line for the roof. So if you want to punch a hole, you click on the edge of the roof, not the reference line of the roof. Okay. For the roof tool, we also have skylights. I think that there's probably a couple of skylights. No, we don't have skylights in the favorites. Um, there are skylights in here. There's a few. I think that it's sort of the simple ones. You would have to go through the settings and set the pens and the fills and the lines and stuff. I really need to go and add favorites for those, I suppose. Um, but these skylights, just like with the doors and windows it's attached to walls, the skylights are attached to the roof. So if the roof moves, the skylights move with it. All right. Let's take a look at one more case for the beam tool. So I'm going to go ahead and draw in like one of the rafters right here, and I'm just going to put it right where my reference line's at. That'll work for right now. Um, or sorry, my section line. Okay, so here's that beam that I have placed. In the case of this beam, I'm going to place the reference at the top of the beam. And you'll notice what happens there is that reference line stays right where it was. So now if I drag this down to here, let's put a reference there, and then I'm just going to stretch this with the pet palette directly in section to that point. All right, so I can take a look at where that sits. Oh, that was not. Hold on. There we go. So now it's bird's mouthed out to that porch beam. But I want this to do something more like, I think that the I think that the as-builts do something like this, where it's actually got a flat piece that soffits over. And we can do that with the beam tool. So what we'll do here is we'll go to the segment settings and we'll add a segment right here. We'll say add, and we'll go right here to the first part, and we'll make this a fixed length of, I don't know, like 2 feet. And we'll give it a taper. And it's always a guess and check. The vertical height starts at 3 inches. There we go. And we'll say okay. And we get that taper. You can also adjust the end angle directly in 3D as well, so you can start to modify some of these segments depending on exactly what the design needs to be. You can even get like some notches and stuff. So you don't have to have really complicated modeling techniques to model really cool rafter tails. It really kind of depends on what the design is. Obviously, like if it's some sort of ornate scalloped profile, there's other things we'd have to do with that. And we can talk about that if and when that ever happens. But generally speaking, unless it's like a historic preservation project, we're not doing a lot of elaborate ornate trim work. So this should get us like 90% of what we need. Now, once you get one of those done and in place, it's as simple as positioning it. Maybe it's centered off of this column and saying that these are spread out at, I don't know, like 32 inches on center, right? And then you can model those rafters out, mirror them across. Once you get one in place, getting the rest sort of dialed in is pretty quick and easy. I think that these end ones would probably have to go away, and these ones would trim to each other. Anyway, not going to have you guys watch me model all afternoon. Just want to get the idea across. So once you get one in place, you can kind of finesse and fine tune it to fit for other conditions. Um, all right, so turning my trace reference off here, let's drop down a story. So the last tool that I want to talk about before we shift gears and start talking about the view map is the object tool. Now the object tool is, best way to describe it is like it's the everything else tool. Right? So it's everything from furniture to appliances to plumbing fixtures to detail parts to basically anything that's a complicated block in ArchiCAD. Now in ArchiCAD, we have the object library. There's quite a few libraries in here now. They've really kind of complicated it on us. But basically, you're going to look at the object library and the Walker-Warner library. Um, what you'll notice is like if I go to the object tool library, for example, go to the basic library and reorganize this. It used to be by CSI division and it's not anymore. So I'm trying to relearn the new system as well. Um, Well, let's just go to, yeah, cabinets and shelves. So if I were to just grab a cabinet piece in here and take a look at it in floor plan, it has a gray fill over the top of it. None of the pens are correct. The out-of-the-box default ArchiCAD stuff is not geared towards our template. Our template pens and fills and everything else have been what they are for so long, and ArchiCAD has sort of evolved while our template has kind of stayed stagnant. And largely because we use our own custom library more than anything else. So, for example, if I go to the Walker Warner Library and let's just pull up equipment and appliances, for example. So, if I'm working in the kitchen, maybe I want a Wolf range. Um, sure, let's go to cooktops. I can grab a Wolf cooktop and drop that in and know that that's going to look somewhat decent. The out-of-the-box ArchiCAD cooktops, again, it's like the door panels, right? They look like something that Home Depot might be embarrassed to sell. So that's why we've curated this whole collection of either generic and yet non-offensive objects or manufacturer-specific objects. So like our electrical lighting fixtures, we have a lot of different manufacturers in here. We have a lot of sconces and there's a lot in here that we've sort of built and curated over the years. McEwen is one that I think one of these is actually this is I think in the conference room, one of these too. Um, there's a lot in here. And we do build a lot of custom stuff ourselves. Every single project will typically have some demand for some custom fixtures. We'll talk about creating custom light fixtures and stuff later on. As an example, the lamp tool uses objects as well. If we go into the lamps in here. They're just ugly. They're horrible. The wall sconces are probably the worst examples of anything imaginable. Like these are never anything that we would ever want to use. And so we always create custom light fixtures or use custom light fixtures that we've built over the years. And those are all in the Walker Warner library and typically in the object tool. So this is an area that I recommend you dig through and get familiar with what we have available in the object tool for the Walker Warner library. If it's in the object library and we want to use it, typically it's saved as a favorite. So again, that star icon. So like plumbing fixtures and toilets. This toilet object is actually using the toilet from the out-of-the-box object. We just have it set with favorites to use the correct pens and fills. So if we go ahead and dump that into here, right, there's a toilet. And the reason we use this instead of our own custom is because it has a lot of different configuration options. We can change what the bowl looks like, how it's mounted, hung, whether it has the lid or seat, and wall carrier, different options to make it pretty flexible and versatile. And it's the sort of thing where like on a toilet, close enough is close enough. On a kitchen faucet, maybe that's not the case. It's going to show up in a rendering. We want the exact faucet. But maybe in a bathroom, a tub or a toilet is going to be close enough to what we need. And you can get there something similar to what we're looking for with the various types and shapes that they offer. Um, okay. Any questions so far? All right.
No, all good.
Well, we'll keep trucking along then. Like I said, it's catch up day, so we're gonna cram through and get through session 2 here. So the next session we're gonna talk about is the navigator, and I don't think I have to go on for another hour and a half on that, um, or hour. I guess we've been rolling. We talked about this very briefly yesterday, but I want to get into the weeds on the various view settings, and really kind of reinforce what the project map, view map, and layout book and how they relate to each other, what they are and how they relate to each other. So here, for example, I placed a section marker right here to work on my building. I'm going to call this Pat's working section. Now, if I come into my project map, right, I have this Pat's working section showing here because that's what I called that section marker. That working section only shows up one time, and that's here in the project map. Same thing for elevation markers, same thing for interior elevation markers. Worksheets and details are sort of specialized things, so we'll use the worksheets for like notes and scratch. It's basically scratch paper. The notes and legends, this is all of the stuff that goes on to the legends portion of the layout book. These are our keynote sections we have down here as text and labels. There's additional notes over here regarding door and window notes and dim points. So this is like all of the various notes that we use in our documents. General notes, this is what goes on our cover sheet, project directory, contact information. It's a lot of kind of scratch paper kind of stuff that goes into our document set. The details, on the other hand, are specific to our different detail types. Now, I recommend every single detail scale and type has its own viewpoint. So if these are, for example, let's say that these are my 1.5 inch concrete details. If I had, I don't know, like 3 inch concrete details where I need to show waterproofing or something like that, that would be a separate viewpoint. So I'm going to go new independent detail. I'm going to call it CO2, enlarged concrete details. Now in here, I've got these drawing templates. If I copy one of those into here, right, this will be my new details here for my 3 inch details. So we'll come down here to the bottom, we'll change this to 3 inch details. Right, so maybe this is going to be I'm just going to drop in a couple of fills. This is going to be my waterproofing detail for a cold joint or something, right? So I've got a detail here that I've drafted out that only exists here in the project map. So what I'm going to do is go into my construction drawings folder in the view map. I'm going to go to exterior details and foundation details, and I'm going to right click on this. Oh, can you release that?
Oh, yeah. Sorry.
I just sent a request to you, so you should see that pop up in your teamwork palette. Okay, so now I can right click and say save current view. And this is where we can really see sort of what the settings are of this detail, or of any view really. So here I'm going to say that this is going to use my exterior detail layer combination is the first view setting. And we've named these all of the view settings in a way that they're cohesive. They all relate to each other. A8 is our detail layer combination. The A8 is our sheet for detailing. We'll use the drafting pen set. I'll use the exterior detail model view options. I'll use the exterior detailing graphic overrides. The renovation filter I'm going to keep as non-remodel. There's a dimension style as a view setting. And then down here at the bottom, I'm going to uncheck this ignore zoom and rotation. Because when I zoom in on this, I'm going to rename it. Call it cold joint flashing and say, okay, so here's that cold joint flashing detail, but maybe I have another 3 inch concrete detail. Uh, I don't know. It's like maybe it's my foundation drain detail. So there's that detail. Now I'm going to right click and say save current detail and call this foundation drain. Right. So if I click on this view, it zooms to my cold joint. If I click on this view, it zooms to my foundation drain. But they both exist within the same concrete detail viewpoint. So on these details, for example, there's a lot of kind of scratch from past presentations, past training sessions. But each one of these might be saved to the view map with its own zoom, its own layer combination, its own view settings. Where this really
And
starts, yep,
I'm
go ahead.
sorry. Is this 3D or is this all 2D?
The worksheets and the details are all 2D. So a lot of times what happens is we might take a building section. If this is what that foundation detail needs to look like, I might take this stuff and copy it and paste it into here. And that's going to automatically convert it to lines and fills. Um, right, so these are no longer slabs and walls and doors. If I look at what I have selected here, it's all lines and fills. Um, but we can
And
take this and reference it back to the model. So it's based on the model. We can also show the section as a trace reference. So we can say show as trace reference. Where are we at here? There it is. So we can draw over the top of, or even, yeah, you can trace out what's actually in the model. You can compare the model to what's in here. You can use your trace palette to actually reposition that model so we can see like how that fits over the top of this detail, and get it to
and
work.
are all details in worksheets? Is that what worksheets are? They're
Worksheets
details?
and details do the same thing. They're both two dimensions, but worksheets are more like the notes and the scratch paper, the door and
Oh,
window
oh.
dimensions, and the details are more about composing and compiling the various drawing details, trim details, framing details, whatever other construction details we're doing.
Mhm.
And that's where like basically what I was saying is like each one of these that has a different function. So like concrete details will all be in one viewpoint, unless they're different scales, and then we split them up into separate viewpoints. The one thing we don't want to see is like just a a detail viewpoint, and then all of the details in the project go into that viewpoint, because we typically have anywhere from like 10 to 50 pages of details, and that can be a lot of details to pack into one viewpoint, and it slows things down. The more content you have in a single viewpoint, the slower ArchiCAD is going to run, even if it's just 2D lines and fills and text.
So I'm sorry, just to repeat what you just said. You have different sections of details because it can get too heavy. Each one of those things gets too heavy.
Exactly.
So
So
you,
that's I have like ceiling details, door details, exterior
I
trim
see.
details. Um, and this is just a framework. It's not that all of these have to be used. Certainly like, if there's like three ceiling details and six floor details, those can go into one viewpoint. They don't have to be split out. It's just that this is kind of a general framework for how we might build this out as we start to develop and cartoon a set.
Mhm.
Um, we also have this set of favorites right here. These are sort of, rather than saving these as favorites, we have a detailed viewpoint that already has objects for different framing, trim, insulation, hold downs, fasteners, steel profiles, different lines and fill types, even different manufacturer specific details. So we have a whole collection of Jada detail objects in here for like lift and slide doors, Lutron pocket shades, different details that you can drop in, either as placeholders or some of these are even still relevant current profiles offered by Jada. Okay. Um, Now, once I have these details in here and I've sort of saved them out to the view map, then you can even start putting in detail references. So if I go to my detail tool over here on the left on the toolbox, let's go to the settings and we'll go ahead and apply a detail marker. And here I can see that I have the ability to place a linked marker, create a new detail viewpoint, which I don't really want to do. I want to use the linked marker or place an unlinked marker, which is just a disconnected marker. It might as well be lines and fills. So I'm going to place a linked marker. I'm going to browse. Now, if you remember, I talked about the project map as having the viewpoints and the view map is having the views. And this is where that becomes important, is that here when I'm deciding what I want it to link to, if I just say the first selected viewpoint and I select that 6-inch concrete or 3-inch concrete viewpoint from the project map, that means that all of these markers are going to, where'd it go? Are going to reference whichever view this is first placed to on the layout. And I want to say that this is only going to be that, say, the cold joint detail. So I'm going to say the first drawing being the view placed to the layout of a selected view being the item saved to the view map. So here I'm going to say that this is that cold joint flashing detail. We'll go ahead and say OK here and OK, and I'm going to draw that detail bubble here. Now it says drawing ID layout ID, and that's because this cold joint view has not been placed to a layout. So if I come to my layout book, and this has the same organization, right? A8 is my exterior details. 8.2 is going to be my foundation details. I'm going to open that up, and I'm going to drag and drop that cold joint right in here. This is not the correct title block, so let's go ahead and pull that from the favorites here. We'll say, okay, there's my title block. And this is where that drawing template frame is really useful is if I snap this to that, it should fit perfectly within the detail cell here. And they are numbered automatically for the details by where they show up on the sheet. Looks like it's maybe a little bit off size, but that's where it fits basically. So now when I go back to my my building section, It shows 8.2.1 because that's the layout it's placed to. Um, and because it's referencing the first time that this view is placed to a sheet, even if I were to, let's say, delete this off of here, right? It's going to show in the section as not having a drawing ID or layout ID. But the next time I place it, or if I paste it back in somewhere, it's going to update to reference that again because the view still exists, even if it's been taken off of a sheet. So that's the best way to sort of the best workflow to cartoon out all the details, save them to the view map, place the linked markers, and you can do all of that before you put a single line or a fill on a viewpoint. So you can identify which details you need, save a whole list to the view map, figure out where your reference markers are going to be set to, and then start drafting out your details afterwards. Gives you a lot of flexibility in terms of identifying the details, saving them, and then getting to the drafting work, because the drafting work really is the tedious part. Um, all right, so let's take a look at those view settings again as they maybe apply to a floor plan view. So if I go to my first floor here, let's come to here. You'll notice that I have things like the door and window markers are showing. Um, let's see, it's showing with the blue fills. If I were to switch this to, say, the document pen set, they turn to gray fills. We're going to talk about attributes first thing tomorrow and why that's medium gray, why this is white. We'll take a look at all of that. But let's just say, for example, I wanted to do a presentation plan. So you can certainly change the layer combination. We do have like APR floor plans as a layer combination. We also have APR, where are we at here? I know that there's a model view option for, yep, A0 presentation. I guess there's a little inconsistent naming convention there. But you notice that the door and window markers disappeared. And that's because in the model view options, there are settings for how doors and windows show up. Model view options are like level of detail controls, how much detail shows. So we can show different column symbols, different beam symbols. We can show slabs that abut each other, cleaning up without the separator lines. We can show and hide zone stamps. Door and windows can show with or without markers. We can even turn off the doors and the windows altogether. If we had say a structural engineer who didn't want to see our door and window swings, you can, I'm not going to request this from you, but you can click here and say that this, maybe there's like a DWG export. Maybe we would duplicate that and say for engineer, and we would say show opening only, and then it would only show the opening in the walls. So if that's something that the structural engineer needed, we could do that. There's different level of detail controls. If you end up working on Marine Way, this might be relevant. How much detail are we showing on the curtain walls? How much detail are we showing on the stairs? How much detail are we showing on the railings? So all these really complex elements like doors, windows, stairs, railings, curtain walls. There is also, oh, there's an elevator option now. So we can show there's an elevator object in the out of the box library. We can show different levels of detail in different plans. So maybe the schematic plan um, is going to show the opening only or simplify it down. And the detail plan is going to show full detail. Um, different detail levels for the door and windows. And then there's also the miscellaneous settings here where we can start to turn objects more simplified. So lower level of detail for objects and plumbing fixtures. And that's anywhere that you see something that says by model view options. So if we look at the window here, for example, and we go to the display option. What's that here? Model display. Yeah, so use local settings versus use model view options. So we can turn the doors and the windows either to have global control or just have like a fixed setting for how they appear. A lot of the objects have the same thing where this toilet, for example, is going to have settings in here for its presentation 2D level of detail by model view option. So if it's by model view option, that MVO here for presentation, we could say that that's going to be simplified for the presentation plan. I don't know that we do a lot of that sort of simplification of our documents other than to send them to consultants. Um, the next view setting after model view options is graphic overrides. So these walls are gray or blue or have black lines or whatever because that's their default attribute. But there are times when we want to show them more simplified. An example of this might be for our reflected ceiling plans. Um, we want to show things like plumbing fixtures and appliances, but we want to show them faded down because they're below the cut plane and we're looking upward. So there's a graphic override in here for reflected ceiling plan floor plans. And what that does is it has a rule. The graphic overrides are a system of rules. Here we say that the rule is for furniture and cabinets on RCP, it's all element types with layers that start with AI or AP. And if it meets that criteria, then we're going to override the line type to be, or the pen type rather, to be pen 55. So here, if I apply that RCP uh, floor plan, might not be showing. Oh, this is on the ArchiCAD layer. That would be why. So if we change that to AP fixtures, then it turns gray because now it meets that criteria. It is on the AP fixtures layer. So we're de-emphasizing everything that's below the cut plane. Another example would be like the presentation solid plans. The graphic override is going to say that we're going to show all of our walls as gray. Or if we come into here, presentation solid cut fills black is actually overriding those fills to have pen 56. We could make that pen 58 or 59, and that's going to show as a darker fill.
Do you know if folks do that for schematics or anything, or is there like a typical?
Yeah, this is pretty typical for schematic plans. I think for marketing plans, we changed the graphic override to show it's the same rule. We just say that instead of being pen 56, that's going to be pen 59 so that they show black. And that's for like marketing plans that we would send out to Architizer or whatever. But we don't end up like having to do a whole ton of drafting and stuff. We have these global controls over how the plans appear from view to view with the graphic overrides. I know that Graphisoft, whenever they do a presentation on graphic overrides in their training, their example is for like fireproofing plans, fire separation plans. You could say that a wall has a fire separation value. There's a parameter down here somewhere, fire resistance. If I said that this wall has a fire resistance of um, 45 minutes, I could say a graphic override, turn all 45-minute walls red, turn all 2-hour walls blue with a hatch. You can override those default attributes. Next is the renovation filter combinations. So here, just like with the graphic overrides, these are set to override elements, show elements, or hide elements. So for example, demolition plan is set to show everything that is existing and override everything that's demolished. New construction is set to override existing and show elements that are new and hide elements that are demolished. I mean, it's relatively intuitive on whether you're showing something or not. But the graphic overrides and where this kind of piggybacks off of the graphic override rules show up right here at the top. The difference is, whereas here I can have a whole set of custom criteria for cover fills white for it to meet the criteria. For renovation filters, the only options I have, if an element is to be demolished and it's going to show overridden, that's the entirety of the criteria, is that it's going to override all types and all elements that are to be demolished. And for our graphic standards, we're showing demolished elements when they're overridden on a demo plan to show dashed with white fills for all fill types. So that's cover fills, cut fills, and drafting fills are all going to show white and dashed. Existing elements, when they're overridden, that would be like on a proposed plan. We'll want to show like new walls as gray, but existing walls as white on the proposed plan to show a difference there. So we're overriding the fill types for cut fills, and we're overriding all pens for fills to be white if it's existing on a proposed plan. Does that kind of make sense? I think it's one of those things like it's a little bit clunky and weird until you actually start getting into it and applying some of those settings. But really it's as simple as like, let me grab all of this. I'm going to say that all of this is existing, for example. And let's just say that this is existing, right? So if I were to say that this wall needs to be demolished, I can set that to demolished, and it's still going to show, oh, actually, let's change the graphic overrides here to floor plans. It's still going to show with its default settings, but if I went to the demo plan, it's going to show gray, or sorry, dashed, because the override for the demo plan. It's set to demo or override demo elements. Now, if I go to new construction, it's going to disappear altogether. And maybe I have like, I don't know, a new wall that over here. Oops, flip that. There we go. Maybe these are my new walls here, right? So I'm demoing that piece and I'm adding new walls here. And I'm going to demo this piece right here. Right. So this
Is
is my proposed plan as
is
opposed to
that what?
the existing plan. Sorry, go
I'm
ahead.
sorry. Sorry. Is that what you would do for 1459? You would just basically save as and then just make them all E, and then
Yep, just
we would.
select the entire model, turn it all to existing right here in the renovation palette, set everything to existing. And then whatever needs to be demoed, you're going to go back through and just like I had to split this wall, right? This was one wall before in the existing
Mhm.
plan, but I had to actually split it right there to say, this is where I'm going to demo it.
Right. Okay. Thank you.
And if we ever got to the point where we're like, oh, actually, we're going to keep that stuff, it's as simple as selecting that stuff and switching it back to existing.
Mhm.
Okay. For most new construction, it's not an issue. That's why we have that non-remodel combination because we want to be able to say that everything is set to show. We're not overriding anything. Okay. Um, I mentioned the floor plan cut plane settings. So that's graphical array renovation. The floor plan cut plane only applies to the floor plan views and each view. So we could have, let's say, like a clerestory plan without having a clerestory story. If that clerestory is part of the first floor, it's really just an extension of that first floor. We could just say that the cut plane for a clerestory plan is going to be at 12 feet, right? So I can go to documents, the document menu, and floor plan cut plane, and I can say that this cut plane is at 12 feet. I can say that the story range is current story and maybe stories above, maybe it's only current story, and we'll say okay here, and we'll save this current view as clear story plan. So you'll see actually that the window that was here does not show up anymore because this is cut well above that. In fact, it's actually cut above the height of this wall. So if I go back into 3D here, let's just stretch this wall up so it's at least 12 feet tall. Now I should be able to see that's cut through. But it is showing the windows below. So I might need to change this to cut only maybe. Yeah, and then it doesn't show those windows or doors because they're below the cut plane for this plan. It will show here because they're within the cut plane for that plan. So that kind of makes, so this plan and this plan are the same story. They just have different view settings to be cut at two different heights.
And to do like clear stories above, like you do you see that too? Or do you see, can you see both planes?
Not on the same view. You can't have more than one cut plane. It's basically this is what we're cut at, and this is the range of how many stories above and below. And in this case, I'm saying oh, I only want to see what's on the first floor. And I want the cut plane to be up this high.
Mhm.
Now, if I were to have, let's go back into 3D here. If I were to have a clerestory window, I'm not going to worry too much about what this looks like. I do want to pull it down though. I guess it probably doesn't matter. But if I have a clerestory window that sits up here, and we do have this actually in the practice model. Let's make it 12 feet wide or something, just so it stands out as different. I should be able to see that as well. Oops. We get to the floor plan here. There we go. So there's my clerestory window. So I can have that as a window on the clerestory plan that probably won't show up on this plan. Oh, so I'm in the wrong spot. There we go. If I did want to show it in this plan, I can set the wall to say projected with overhead, and then that window should pop up here. Let's see what this is set to. It's always a combination of, yeah, that's,
So it is possible, is what you're saying.
Yeah, yeah, I can show the window above here. So this is projected with overhead, so I would have to come in here and figure out my overhead line type needs to be dash,
Dash. I
and then
see. Yeah.
it's
Okay.
show dash. It's a whole juggling act of different view settings. It's possible though. Honestly, every time I feel like I'm reinventing the wheel, every time I have to troubleshoot the
Hmm.
overhead doors and windows. Um, let's see here. So let's talk about the layers and layer combinations really quickly. So these are a view setting. The layer combinations are a view setting. They're named just like they're named and organized in the same way as the layout book. And then we have our different layers that are either on or off, locked or unlocked, solid or wireframe. And then this intersection group right here is whether or not elements interact with each other or not. So an example of where we wouldn't want things to interact would be maybe for beams, where maybe we've got like a rafter and a fascia. So if I look at maybe this is like a barge rafter, right? So it has a slope to it and the fascia runs into that. Notice that that doesn't look pretty. It doesn't miter out quite right. So this might go into the roof non-intersecting layer. Turn that on here, which is always a group two. And that means that this element, which is in group one, is not going to interact with it. So at that point, like we can basically just position these things wherever they need to be relative to each other and not worry about how these might miter together. We could clean it up if this is my operator, and this is a target and subtraction, get that to clean up. But I don't want them to miter together because sloped beams and horizontal beams don't play nice together. If it were a rotated beam, let's just do it this way. So this thing is sloping at 11.07 degrees. This beam was rotated at 11.07 degrees. Then it doesn't matter because they can run into each other. They will clean up to each other. Right. So if these are at the same angle, then it's fine. It's only when one is orthogonal and the other one is sloping that they won't clean up. And there's other places that you'll run into this. It might be like at I don't know, a stair skirt board or something like that. Handrails, guardrails, wall caps, all sorts of things where you have a sloping um, beam and a non-parallel beam that's intersecting with it that is not sloping or rotated. But that's the layer group basically. Now you can have any number of layer groups, but we only use three, and that's zero is the layer group for things that are not visible, and that's so that they don't intersect and interact with things that are visible. So if you have trying to think of conditions here where um, maybe you have a wall that only shows in an attic or something like that. It could potentially intersect with something in an elevation that you don't want it to. And in that case, you might set it to a layer that's, if the layer is not visible, you'd want to set it to layer zero so that it's not trimming things out in your elevation. Zero basically will not interact with anything, even other elements on zero. If I were to put both of these beams on the ceiling layer and make the ceiling layer visible, they're not going to intersect with each other because zero does not intersect with zero or anything else. One is just the standard default. This element is visible. The wall exterior layer, for example, is the exterior wall layer is visible for pretty much everything, and it's set to group one for everything. And then group two is for all of the non-intersecting things, sort of those special cases, like trim elements and beams that we want to be visible, but we don't want them to interact with the other things. So this would be like on the A roof trim layer, and this would be on the A roof non-intersecting layer, so that they don't interact with each other. All right. And then the last view setting to talk about are the pen sets. Pen sets, really simple. We do have these sort of all red, all gray, all black pens. That's if you're bringing in like a survey or as-built drawings from an as-built service. I usually want to look at those things with their all of their pens set either black or gray. I set up the red. That's actually for site plans, my preferred. When I drag in a DWG for site modeling, I set the DWG to use this pen set so that I can see like everything that's red I know is on that reference. And then when I draw over it with my mesh, I'm basically masking out the red with black so I can see what I've done and what I have left to do. Um, the drafting pen sets, this is the one I want to talk about right now because this is our primary pen set. These are our, like it says, the drafting pen set. This top row is set to gray because these are out of the box pens and we don't want them to show incorrectly, but we also don't really want to use them. So that's why under description, they're all set to not used. But if you do inadvertently like place an object or something from the out of the box library, it's just going to show gray. It's not going to show mauve or something incorrect. It's just using these pens. Um, all of these pens that are groups of three, this is sort of old school AutoCAD pen logic in a way. Um, it doesn't necessarily make sense in terms of graphic standards, but they're pen groups based on their function. But they're all the same three pen weights. If we look at what they are, it's 0.05 millimeter, 0.15 millimeter, and 0.3 millimeter. And that's the case with all of these pens groups of three. They're just used for different functions. So the green pens are doors, windows, and skylights. These mauve pens are for casework. That's any sort of furniture trim, cabinetry, finish elements that's attached to the building. The lavender are furniture, and that's any sort of furniture piece, cabinetry, casework that's not attached to the building. So that could be appliances, it could be furniture decoration, sort of entourage content, vehicles, whatever else goes into ArchiCAD, uses those lavender pens for furniture stuff. Down here is landscape. That's any sort of site, grass areas, planting beds, stuff like that tied to the landscape component. The golden pens right here are mechanical. That's ducting, supply return, any mechanical equipment. More and more, our consultants are providing that for us, but we still have those pens in there. Plumbing, and this is any kind of plumbing or plumbing accessory, toilet sinks, faucets, tubs, showers, pans, heads, etc. Um, Over here, the yellow are electrical. That's fixtures, switches, outlets, plugs, anything we might put into our model junction boxes. Red is structural. Again, we're not doing a lot of the structural modeling anymore. We're getting IFC files from our consultants, but those pens are in there. Civil, this is going to be our site model, contours, driveways, roads, paths, anything tied to the civil plan or the site model. The chartreuse pen I've called vertical circulation, but that's any kind of stairs, railings, handrails, guardrails, elevators, dumbwaiters, escalators, any sort of vertical circulation or fall protection is going to use those three pens. And for all of these, really, it's primarily the first or second pen. If you think about a faucet, if you had a faucet that had any pen that was 0.3 millimeter, it's going to show up as a solid black blob. So generally speaking, things like that are all going to use the lightest pen. Um, I'm going to get to this group of pens last. These are our composite pens. And this sort of leads into our session we're going to jump into tomorrow morning. So I'll end on that note. This group of pens right here, these are our drafting pens. We do draft over the top of our elevations in order to give like that depth of building because there is no effective way to show like building outlines at varying thicknesses. So these are literally just a 0.01 to 1 millimeter pen as drafting pen weights. They're also used for details or supplementing interior elevations. These are the fill pens, so that's the fill pattern. If you imagine like, oh gosh, I don't know, like maybe there's like a panelized siding where there are 4 by 6 panels or 2 by 8 panels or something like that. The panels are pretty large, so we might use a little bit darker pen, but all of these are the same pen weight, 0.02 millimeter. As opposed to like maybe we've got like a 2-inch octagonal tile. We wouldn't want to show that with a super dark pen because it's just going to punch out. So we have super faded pens for stuff like that, where it's like a really dense fill pattern. We want to kind of fade it out and dumb it down. Um, this is our logo pen. These are white pens for a special use. Um, these are Sandrine's presentation plans. These are the RGB codes that she uses in InDesign. Unless you're working on presentation plans with Sandrine, you probably won't need those. These are presentation plans for our own floor plans. Um,
Can I
basically,
get you to grab some samples? You sure can.
um, basically, if we did a presentation plan where we wanted to show like water or
Yep.
something in the plan blue, we have that pen there. If we want to show grass kind of green, they're just non-offensive pastelish plans for presentation. Uh, this row right here of mauvish pens, these are our annotation pens. So that's like text, leaders, dimensions, all of that stuff. If you're using those tools and applying the favorites, um, that'll already be applied. So not a whole lot to worry there. These are all nonsensical pens. These used to be our logo colors. They're not anymore, but they're still hanging in there. These were a request somebody wanted, a project manager wanted non-print pens. So under the document pen set, those turn white, but otherwise they're
What are
marker colors.
what
Um,
are those used for?
they're not, and they shouldn't be. And the reason for that is because if you turn a pen white and that pen is going over the top of something else, it just masks that thing out. There's no such thing as
Mm,
non-print in ArchiCAD. Non-print is the layers off, basically, or the elements otherwise not visible. But somebody made the request, and we it ended up in the template, and it's just been hanging on. If you do need like a red markup pen, that's what these pens are for. We have these markup pens specifically to dump text onto a layout. So for example, if I went into my foundation plan and I wanted to leave a note for the D1, I would grab that pen 196 and I'm going to make a note there and leave that to them to fix. I know most project managers will use like Bluebeam for that, but you can dump notes directly onto the layout as well. Let's see here. So looking at that other group of pens, if we zoom in here, and I'm going to go ahead and just get my cart and my horse mixed up here and dump in a wall right here, right? So here's a concrete wall, here's a framed wall. You can see how they intersect because they're building materials. We're going to get into that tomorrow. But I want to talk about the pens that are used on these kind of complex elements. So if we look at the pen set here, right, under drafting pens, this row of pens plus this pen right here are all the pens for framed composites. So the core of this is blue because pen 22 is blue. Um, the finish and sheathing are white because pen 21 is white. This little green line right there, that's also pen 21, so that goes away. Because on our quarter-inch plans, we don't want to show, whatever 5/8 inch plywood, 1 inch air gap, 3 inches of furring, siding, whatever. We just want to show like, here's the framing, here's everything that's outside of the framing. Simplify it down for the quarter-inch scale. Now, if we go to the detail plan pen set right here, notice that all of these change. So first of all, this white becomes gray and this blue becomes white. What that does is those separator lines and the fills here basically are now showing with that gray pen, with that pen 21. And the background for those is using pen 41. This pen is still a light gray. Well, it went from blue to light gray, and then these pens are black. We do sort of buck the system in terms of graphic standards, industry standards, and that our core pen is going to be this pen 24, and that's the heavier line weight. And then the outer pen is pen 23, and that's the lighter line weight. Um, we did a ton of test prints and plots years and years and years ago, and the graphic standards team at the time decided that this is the graphic that we wanted to go with. So that's what we use is pen 24 is the core line pen, and pen 23 is the outermost line pen. Now this other row down here, the mauve pens and this pen, they're the same functions, the same pen weights, just for concrete. So the difference there, if I go to my documents pen set, is that the core pen for concrete is a medium gray. The core pen for framed elements is a light gray. So if we look at what that means, this concrete thing shows with a darker gray than the framed element. But again, if we switch to the detail pen set, right? I get that concrete with the concrete fill. And the nice thing about that is if I copy this and paste it into a detail worksheet, let's turn off that trace reference. Right? And then apply the detail pen set. I don't have to go back through and redraw all of my fills. All of this stuff is already in there. And that's not to say that this is like foolproof and we don't ever have to touch any of these fills, but at least some of the legwork is done. All right. Um, the other pen sets, so that's the detail pen set, and then we have our document pen set. That's eliminating those fills and those separator lines. And then we have our printing presentation pen set. I don't know that there's a lot of difference other than maybe these are color in presentation and white in documents. The reason for that, if this was say a wood or a tile floor, I could, for example, let's just say that it's tile. So make it like a 12-inch grid. Cover fill would be something like that. And then maybe the background fill, maybe I want to show this with like a fill in my presentation plans. So I get that fill in presentation plans, but then when I go to my document set, it just shows white. So I don't have those color fills showing in the background. And that's what this group of pens right here is for those presentation plans. And then we have printing documents and we have printing 1 to 200. And this basically just takes every pen weight and drops it by 50%, or most of them anyway. Anyway, so that's for things like site plans, plot plans, whatever. Just drops down the pen weight so they're not quite so bold.
So when you're like driving around a model, the pen weights are always the colored. Like, do you ever want to look at the drawings as if it's going to be presentation mode, or is it's
Yeah,
just only when you're on the paper space, or yeah, I'm using the wrong words, but you know what I'm
yeah,
saying?
yeah. In the view, a lot of times, well, I don't really use the detail pen set unless I'm drawing details. But yeah, a lot of times I'll just work in the document pen set because the colors are distracting. At the same time,
Hmm.
like it does give you an indication of whether or not the pens are correct. Um,
Hmm.
but generally speaking, if we go to the layout, for example, this drawing on the layout, if I go to the settings of it, has its own pen set. So I can say that this is the detail pen set. And then those are going to be those detail pen colors. So that's really where we're defining what those final pens are. So we don't need the view to be saved with the pen set we're going to use. We come into the drawing on the layout and we set which pen set is going to be used there instead.
I see. I see.
And then additionally, here's another like sort of word of warning. Is the layout book has a pen set and a layer combination for the entire layout book. So notice it says custom right here. And Joyce actually has her own layer combinations reserved. This is a weird, it really is a bug, and they just refuse to fix it. But I can come into the layout book and I can change the layer combination that's being used in the layout book. I can change the pen set that's being used in the layout book. So pens and colors for the layout book, I can change it to a different pen set. And I don't have to have the layout book reserved. I don't have to have the pen sets reserved. So it's this weird thing where like if you do need to adjust a layer combination, don't do it while you're on a layout. Go to the view, go to your layer combinations, make the change, and then go back to the layout and double check that that shows up correctly there. Otherwise, you're changing the layer combination for the whole layout book.
Yeah, that's dangerous.
Yep. Yeah, it's most things on the in the layout book should be on the ArchiCAD layer. The ArchiCAD layer is basically layer 0. It's the generic always on. You cannot turn the ArchiCAD layer off. But that's not always the case. There are times when maybe we'll put in like revision markers and we'll want to turn the revision marker layer off when we're ready to issue the next revision or create a new revision layer. So the layout book does have its own layer combination set to layout book, and we don't want to adjust another layer combination. If I want to change the roof plan layer combination and I make a whole bunch of changes here, now my layout book is using the roof plan layer combination instead of the layout book layer combination. Okay. So
Okay.
I think for the remainder of the day, the next hour, hour and a half or so, um, Joyce, keep trucking along on your model. It's looking great. Kelly, I did get the file open. I didn't know if you had a chance to get to anything yet, but I think if you
No.
start laying down some walls, start looking at the beam and the column tool. And honestly,
Yes.
even just the rest of the day today and anytime you have before we meet tomorrow, just start dropping in model elements, get familiar and comfortable with, just basic modeling. One thing to remember, and I say this because when I learned ArchiCAD 20 some years ago, I had been working for the better part of like 3 days before I went to my boss, and I said, "How do I make a wall that's exactly a set distance?" Because I was just sitting here going, "Well, that's about 12 feet, right?"
Oh, yeah.
Don't forget to hold shift. That's going to lock to that axis. So it's not
Yep.
accidentally snapping to like 0.0001 degrees. So hold shift and then R is going to be radial distance. Shift R is like tip of the day, like commit that to memory. Shift R and then say that that's 12 feet. Shift R, say that that's 15 feet, right? So use Shift R to lock to an orthogonal axis, and then R is going to be the numeric input. And the reason that Shift and R is great is because once I'm locked to that axis and I hit R to tab into the distance, I can move the mouse wherever I want, and it's not going to throw the angle off. I can type in the distance and hit enter. You can also tab through this. So if I did want it to be at a 10-degree angle, I can type 10 degrees. Or I can type X and Y coordinates. So I can say it's over 12 feet, up 20 feet, and define the coordinates for that endpoint.
And
Um,
how are you toggling between all those things?
just
Just
hitting tab.
CAD. Okay.
Or the direct shortcuts are R for radial distance, A for angle, X for X coordinate, Y for Y coordinate. One place that I really use the XY is like if I'm drawing something that's rectangular, let's say like a slab or a morph or a mesh or something. You can use the geometry method of a rectangle, and I can type X20, Y20 and get a rectangle rather than using the polygon method and typing Shift R20, Shift R20,
Mhm.
and then dragging it around, right? So it's a fraction of the time to type X20, Y20. Okay.
Okay.
All
Thank
right.
you, Patrick.
Yeah, I know that's a super packed session. I know that I talk really fast and we cram a lot of information in. So if you get stumped on anything, feel free to reach out. We can jump back on another Zoom call. If it's nothing like urgent and you want to just answer questions before tomorrow's session, that works really well as well.
Well, thank you.
All
Thank you
right.
Can
very
you share the
much.
recording as well to refer back
Yes,
to?
I will load the recording. I create playlists generally. I forgot to record yesterday's session, but I
Mhm.
create private playlists on the Walker Warner YouTube channel, and I can send you the playlist so you can go back through and scrub through the videos
Oh,
if you need to.
sweet.
Great. Okay.
Thank you.
Thank you.
Yep, I'll make sure
All
that
right.
that gets uploaded before the end of the day.
Mhm.
Thank you. Take
All
care.
right. Have a good evening.
Thanks, you too.
Bye.
Bye.